Hi, I'm Ken Collins. Welcome to my supplement video to the engine swap series that I produced a few years ago. In this video, I'm going to explain the procedure to change a EEC IV speed density system, which I have in this car, over to a mass air system. Okay, if you're not familiar with the EEC IV system, I urge you to find a book on the subject, learn as much as you can. It will help with troubleshooting at a later date. Now, in my engine swap series, volume 1, I go into the details that's needed for, in this case, pulling the turbo 4-cylinder out and putting a 5-liter in. I also used an AOD transmission. If you had a Fox Mustang or, Fairmont, little LTD, it's very much a similar procedure. I talk a lot about the 5-liter engine. I go into valve train geometry, talk a little bit about camshaft design, how you check piston to valve clearance, degreeing a cam, that type of thing. In volume 2, I get into the electrical part. Now, to keep the project simple, I decided to go with the speed density system, which was the earlier version that Ford used. And as long as your engine is fairly stock, it works just fine. Now, in my case, I'm using an Explorer 5-liter. It has GT40P heads. It's got the Explorer intake. I am retaining the 60mm throttle body, which would have been normal, a normal stock throttle body on a 5-liter GT Mustang. But I did change the camshaft. And this cam is supposed to be what they call speed density friendly. But I did find that the intake vacuum is slightly lower, at idle. And that does throw the system off slightly. The map sensor, which is reading intake vacuum, when it sees that lower intake vacuum at idle, it thinks that there's a slight load on the engine, even when there's not a load. Now, at wide open throttle, your intake vacuum essentially goes to 0 and the car runs fine. At the drag strip, it goes high 13s on motor, and that's with a stock torque converter. And it's been 1240s with 100 shot of nitrous, good top end, good throttle response, but it does have a poor idle. I find when I start the engine up, it revs way up and it'll idle way down and it may stall. Start it back up, put it in gear, it stalls. If I 2-foot it to keep the thing running, if I accelerate real quick and let off the throttle, it may stumble, cut off. And I was able to put up with it for a couple years because this isn't my daily driver. It's mainly just driven on the street just to get me to the drag strip. But I felt like, let's get a little bit better drivability on this car, and the best way to do that is to change it over to mass air. So back when I did the wiring for this car, I put in a few provisions in the anticipation that at a later date I may change it over to mass air. Now, to do the conversion, it's really pretty simple. A lot of times on the internet you'll see plenty of information out there, but there's some misinformation and there's some confusion with people on what wires you splice into. So I'm doing this video to kind of clarify that. Now, to get to the EEC IV processor on this car, as it is with any of the Fox-bodied cars, the processor is up inside the right-hand kick panel, so you have to pull the trim piece off. You take that little strap loose, pull the processor down, and remove the 60-pin connector. Now, it's a little bit hard to shoot down in that area, so for illustration purposes, I'm going to go back to footage that I shot a few years ago when I did this engine swap. It'll make it a little bit easier to see what needs to be done. So now let's go to an earlier clip where I have the 60-pin connector drawn on a whiteboard. I show the layout of the pins, talk a little bit about where the pins go and what they do, and then we will get into the modification phase. So let's start by looking at the diagram I have here of the 60-pin connector, and we'll show how it's numbered. Okay, first you want to look at the connector, so the two locating tabs right here and right here that engages slots on the PCM is on the right hand side. And what you will find is that the number 1 pin is right here. It's at the lower left, and then it goes up to pin 20 at the top. Then it starts again 21, goes up to pin 40, then it goes down here to 41, and then up to pin 60. Let's take a look at the diagram. Most all of the wiring diagrams will show the connector in this orientation, where you have the tabs on the right hand side. Your number 1 pin is here, lower left. They go all the way up here to pin 20. You see 40, 60, 21 at the bottom, 41. And when you look at the connector itself, it's really easy to make sure that you're oriented right, because the 60 and 40 pin are the main grounds, and they are almost always black with a green stripe, and they are fairly large gauge, usually 12 gauge wires. Also, the number 20 pin is a ground. It's usually just a black wire. So if you see black and black with green wires across there, you know, when you flip the connector around to take a look at the back, you know you're in the correct orientation. Now let's go over the pin connections that are very important to get the EEC system to run. These are the connections that pretty much have to be hooked up. And I want to go over the pin locations and talk just a few seconds about what each pin does. Now the number 1 pin, remember that's in the lower left on your EEC connector. That is the KAM, keep alive memory. That is hot all the time. There's always 12 volts on that connection. That is to maintain memory in the processor. It will hold codes if you have trouble codes, and it will also hold adaptive strategy. Over a period of time as the car runs, certain software changes will take place to give you a good idle. It'll compensate for different variances between engines, and that needs to be kept with 12 volts at all time. Happens a lot, especially on the older cars. I can remember where people said, the car's been running fine, but my battery went dead. I had to replace the battery, and now it idles terrible. Well, that's because it lost that idle strategy. In many cases, if you just keep driving the car, it will relearn it and go to working just fine. Pin 4 is the IDM. That's the ignition diagnostic monitor. That's there to make sure that the ignition is firing. If it sees an open in that connection while the engine is running, it will read that as a misfire or some type of problem with the primary side of the ignition, and you will get a code for it. The number 7 pin is ECT. That's engine coolant temperature. That's getting a voltage signal from the engine to tell you how hot the coolant is. The number 9 pin will be there for the mass air sensor if it is a mass air equipped car, and that essentially is the ground wire for the mass airflow sensor, the MAF. Now number 12 to number 16, from 12 to number 15 are fuel injector wires. The number 16 pin is the ignition TFI ground. This is going from the processor to the TFI for the ground for that ignition component. Number 17 is STO, or self-test output. That also goes to the check engine light, and it's part of the self-test connector. Number 20 is the TFI ground and the case ground. That's that short ground wire that comes right off the 60-pin connector, and it's bolted right to the fender well, or the kick pad area inside the car. Number 21 is the IAC, or the idle air control. That's for the idle bypass solenoid to change your idle speed. Number 22 is the signal wire for the fuel pump. In other words, it goes to the fuel pump relay, turns the fuel pump relay on and off to turn the pump on and off. The number 25 pin is the ACT, or air charge temperature. Now, I think in most modern books it will be labeled as IAT, or intake air temperature. Of course, that's a voltage reading coming from the air induction system to let the engine know what the temperature of the incoming air is. Whoops, I forgot to put pin 26 on the board. This is a very important pin. It's the reference voltage pin. It gives a 5-volt reference to all of the engine sensors. Some of these sensors are a variable resistor like the ECT and the ACT. The TPS sensor, throttle position sensor, is a potentiometer. And the map sensor or baro sensor uses a frequency to send back to the PCM for its signal. All of these sensors need a constant 5-volt reference to operate. The number 29 pin is the right-hand oxygen sensor signal. That's getting a voltage signal from the right-hand oxygen sensor to let the processor know if it's running rich or lean. The number 30 pin is the transmission load sensor. What's that is there for? In a straight shift transmission, it lets the processor know when it's in neutral. It changes idle strategy, it changes emission strategy slightly because there's no load on the transmission. Once you put it into gear, then the processor knows that a load is about to begin. It changes strategy, timing strategy, idle strategy. In an automatic transmission car, you essentially have the same thing. The signal is grounded when you're in park and in neutral, lets the processor know that there's no load on it, changes that strategy mainly from an emission standpoint, and when you put it into reverse or drive, something like that, it goes to an open circuit, and that lets the processor know that a load is about to begin. The number 30 pin is probably not really needed on a straight shift, especially if you were putting this in a street rod or something like that. It may be slightly more important on an automatic transmission car because it's letting the processor know that there is a load when you put it into gear. It's less likely to have a stall or something like that when you put it into gear because it's anticipating that it's going to be into a load. The 36 pin is the spout connector. That's spark output. What that is the incoming signal that's coming from the distributor. It sees that the outgoing signal on the spout will manipulate the timing. It makes the timing advance or retard depending on engine load. That's a lot of people will talk about a little shorting bar that you have to remove to set the base timing. That's that spout wire there. The number 37 pin is vehicle power. That is the wire that's a fairly large gauge wire, and it's coming from the EEC relay that sends power to the processor to power it up. And it actually shares 2 pins. 37 is one of them. Number 40 is one of the power grounds. Remember, that's the number 40 and the number 60 pin are large gauge wires. It's normally black with a green stripe, and those are the main power grounds for the processor, so all of these various circuits have a ground. That's why it's a fairly large wire, and there's actually 2 of them. You want to make sure that you have a very good ground there. Number 42 is another injector wire. 43 is the left-hand oxygen sensor signal, getting a voltage, going to the processor, letting the processor know the left bank, whether it's rich or lean. Number 45 is the map sensor on speed density system, manifold absolute pressure, and on a mass air equipped car, it will be the baro or the barometric pressure sensor, signal wire. The number 46 pin is signal return, which is just another name for the internal ground for all of the sensors. All of the sensors that need a ground go to that pin, so all of the sensors have the exact same ground signal as each other, so all of the signals are consistent. It has a dedicated ground, which is called signal return, number 46 pin. The number 47 pin is TPS, throttle position sensor. And of course that's giving a voltage signal that varies with the throttle position. It typically has a low voltage at idle, you know, with the throttle closed, and you have a higher voltage with it at wide open throttle, and it's linear between, you know, the angle change of the throttle. Number 48 is STI, or self-test input. That's that single wire that's where the self-test connector that you hook your, you know, self-test code reader to, it's the single wire that's by itself, STI. 49 is a dedicated ground for the oxygen sensors. That's usually an orange wire that's actually bolted to the back of the block or the back of the intake manifold. Dedicated ground for the 2 oxygen sensors. The number 50 pin will be the signal wire for the mass air sensor if it's a mass air sensor equipped processor. Now, if it's a Crown Vic that's a speed density system, the number 50 pin may be used for the integrated speed control. But on all your Mustangs and Thunderbirds, that typically is an open wire, and you only have a wire there if you have mass air, the mass air system. The number 52 pin is another injector, happens to be injector number 8. The 56 pin is PIP, or Profile Ignition Pickup. That's actually the signal coming from the distributor to let you know that you know, you're firing each cylinder. In other words, it's very similar to the old points and a points and a condenser ignition system of the old days. It's making and breaking, and that's letting you know when it's time to fire the coils. Okay, and the number 57 pin is the other vehicle power wire. It goes along with the number 37 pin. Both of those wires are fairly large gauge, and they're coming from the EEC power relay to power up the processor. The number 58 and number 59 pin is injector 1 and injector 2. Now, on a sequential fuel injected car, which is what we're dealing with, you have a separate wire for each injector. On the systems like the pickup trucks, for instance, and this old turbo coupe, the 4-cylinder that was in it, you did not have sequential fuel injection. You had bank injection. So half of the injectors shoot on one crank cycle and the other half shoot on the next crank cycle. And that tends to be those 2 wires. If you have a bank injected system, you know, like the turbo coupe had, you would have 58 would power, you know, half of the injectors, and the 59 would power the other half of the injectors. And then of course you have pin 60, which is the other power ground. Remember, the number 40 and the number 60 have a large gauge wire. It's the main ground coming directly from the battery ground cable right to the processor. Okay, hopefully that was a good overview, told you the position of the wires, a little bit about the function of most of the wires. Now we're going to get into the actual modification to change it over to mass air. And for illustration purposes, again, I will show clips that I shot back when I did the engine swap video, where I have the EEC harness laid out on the table just to make it a little bit easier to see the wires that need to be added and spliced into. So let's go to that now. Now, while I'm changing the position on those hard shells, I want to do one more thing. I want to add the 2 wires that will be needed at a future time in case I want to change this over to mass air. Remember that pin 9 and pin 50 go to the mass air sensor if it's equipped. So I'm going to add those 2 wires to the hard shell now, and so it'll be ready when the time comes. Now, to do that, you have to take this little plastic retainer out the bottom of the hard shell. I usually just use a pick tool and get underneath of it, and you can just kind of just carefully work the ends here, and it eventually will come up, and you can remove that. That's so you can get to the tabs and release the tabs if you need to. Now in my case, I'm adding wires, I'm not taking them out, so I don't have to depress those little tabs. However, if you need to, you can take a little pick tool and you go right down in there past beside the terminal and release the little tab and then pull the wire out. In my case, I'm just adding wires. So I'm going to add two little wires here. I have this little kind of tan color one. I'll put that in the number 9 position. So remember how this is numbered here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I will just take the wire and put it right in there. Okay, now I'll put number 50 in, and that one goes in this location right here. And we'll put the plastic insert back into the hard shell. Just like that. Now that I've added the 2 wires to the 60-pin hard shell for the mass air sensor, I thought, well, this is a good time to go ahead and add the 4 wires that are needed for the mass air, have it go out under the hood to some hard shell connector, so it will be ready when the time comes to plug one in. So I thought, well, what's out there that has a 4-wire harness, has a male-female connection, and it's readily available? So after thinking about it for a while, I came up with this. A trailer wire harness. It seems to be the perfect thing. You have fairly stout wires. I believe these are about 16 gauge. You have a male-female connection that has nice, good terminals. You'll have very little trouble with resistance on those. They're nice and big. You have a short section here. This could easily go to the hard shell connector for the mass air itself. And then this other piece has about a 4-foot long wire, and this could be tied into the EEC harness. I figure, well, you have, one bare terminal here that could go to the ground, have the next one go to pin number 9, have the next one go to pin 50. Those are the 2 connections that we added, and then the last one be the hot wire, which would actually go to the pin 3757 on the processor, which in turn comes from the EEC power relay. So I looked at my harness, and of course I have these, the 2 wires that we added, and the ground and the hot wire, of course, have already been, I've already put the butt connectors on them, these extensions here. So I decided, well, what would be better, instead of, adding another butt connector or something like that, I'll solder those connections into place. So we'll do that now. We'll start with the ground connection. Remember, this is black with a green stripe. This goes to pin 40 and pin 60. And I've stripped back a little bit of wire here for the white terminal, which we'll use as the ground. And I'll make a good mechanical connection on this by spinning it around all the way around that part of the wire that I've taken the insulation off, right here. Just like that. Now we want to solder that in place. Okay, I'll warm up my soldering gun here, and I'll take some solder and tin the end. That'll help transfer the heat. And remember, you have to use rosin core type solder. That's the only thing you can use on electrical connections. Now I'll take the soldering tip and put it right on the connection to warm it up. You let the solder flow right into the connection, just like that. Perfect. Now I'll do the hot wire. Remember, this is going to the pin 3757. Wrap the wire around the area that I've stripped off and solder that one. Now the brown wire to the number 9 pin. The yellow wire will go to the number 50 pin. There you go, heated up the shrink tubing on 2 of the connectors and put electrical tape on the 2 solder connections. Okay, along with the 4 wires that are new for this conversion, there's a 5th wire that could be added. And that would go from pin 19 of the 60 pin hard shell back to the hot side of the fuel pump. Because the mass air system has a fuel pump monitor. So when you start the engine up and the fuel pump relay comes on, that pin 19 should be hot, and the processor sees that voltage and assumes the fuel pump has come on and that the relay is working. If it doesn't see voltage, it will create a trouble code, could cause a check engine light, but because it has no effect on the running of the car, I'm not going to add it for this project. Now let's take a look at that mass air hard shell and verify the wires. Okay, you can see I've already added the mass air sensor into the air intake, and this is the stock style mass air unit that was for the Fox Mustang. In other words, Mustangs up to 93. In 94 and 95, when they went to the SN95 platform, they have a mass air sensor that has a slightly larger hole in it. This one has a 55mm hole. A lot of people feel it's a little bit restrictive, but it is the stock mass air for this, so that's where we need to start. And of course, here's the trailer connector that you saw in the earlier video. And again, you know, if you're never going to change this to anything other than the mass air, you could make this permanent. There's no need to have this. I did that, of course, because this is a project car and I may be making many changes over the time that I'm doing this. I also have the hard shell that goes onto this mass air, and I've already wired it to the little trailer hookup. So now let's take a closer look and see how it's wired. Okay, I'll hold the hard shell connector so the clip is facing down and the pins are facing the camera. The first one here on the left hand side, which on this one it's a red wire, but you can't always go by color code, of course, but it's the one that's going to pin 37 and 57 of the EEC harness. Remember, that one is hot anytime the ignition is on or anytime the EEC power relay is on. The one next to that will be the ground wire. Next to that is the one going to pin 9 of the processor. That's a signal return of the mass air sensor. And the one on the right hand side here, that one is going to pin 50 of the processor, which is the mass air signal wire. Okay, if you're following the way I'm using the trailer hookup, you'll see that, of course, this is the other side. So this one with the little sheath around it, that one actually hooks into the bare terminal on the other side, and I have that going to ground. The next one, I have that going to pin 9. The next one's going to pin 50, and the end one is going to the 3757 pin of the processor. Again, if you're making a permanent installation, you don't need this at all. Okay, I'll go ahead and plug in the hard shell connector, and on the other side I'll plug in to the trailer harness. Okay, let me give you a little tip now, and that is anytime you're taking that 60 pin connector off a processor or putting one on, always disconnect the ground cable of the battery. We don't want to create any short circuits, and it's really just a good practice. Now we need to take the speed density processor out and put a mass air processor in. Now there's 2 main designations, and that is goes by tear tag. And the tear tag will either be an A9P or A9L. The A9L is typically a 5-liter with a straight shift or T5 transmission. The A9P would be for an automatic 5-liter or a car that has an AOD transmission. Now there's no problem using an A9P processor, the automatic one, in an automatic or a stick car. However, the A9L should only be used in a stick car. And the reason is the pin 30. Pin 30 reads either a ground signal or an open circuit on a stick car to let it know whether you're in gear or you're in neutral. In an automatic car, it's essentially doing the same thing, but it's looking for whether the car is in park or it's in gear. By being in gear, the processor knows that there's a load getting ready to go on. It changes idle strategy, load strategy. And of course, the reason you really shouldn't mix them up is because on an automatic car, during startup, that pin will go to 12 volts. And there's a protective diode in there to keep from having any kind of problem with 12 volts being introduced. However, on the straight shift processor, that diode may not be there. And so because it's only looking for an open circuit or a ground, when it suddenly gets 12 volts introduced to it, it may burn out a little ground strip in there. So a word to the wise. Be careful. If you got a stick car, no problem. But if you have an automatic car, you should be using the A9P version of the processor. Okay, we've swapped out the processor. I've put the ground cable back on the battery. And there's one more thing we need to do under the hood. You'll remember when we were looking at the diagram that on a speed density car, you have a map sensor. That's this right here. And there's a vacuum hose that will be going to intake manifold. And so that lets it read intake manifold pressure at all times, lets it know what kind of load it's in. Now on a mass air car, you don't have that. Instead, you just have a barometric pressure. So it's only reading atmospheric pressure. It's really the same sensor. So all we need to do is disconnect the vacuum hose, and we don't want to plug it off. We want it to be left open so it can read atmosphere. And of course, the vacuum tree I took it off of, I need to put a little nipple there so I don't have a vacuum leak. And we have essentially changed the map sensor to a BP sensor, or barometric pressure sensor. Okay, I just came back from a road test, and you heard when I started the engine it had a normal fast idle, came down smoothly. When I put it in reverse to back it out of the garage, there wasn't any hint of it trying to stall. Driving it down the road, good drivability, and a very stable idle. So as long as it doesn't change the performance of the drag strip, I feel this is a very worthwhile upgrade. So if you're having problems with your speed density system, I would urge you to consider changing it over to mass air. Thank you very much for watching this video, and as always, good luck on your projects.